welcome to the Deep Dive. Today we're taking on a topic that sits, well, right at the intersection of innovation, consumer confidence, and some pretty cold, hard physics. We're talking about EV battery thermal safety.
Yeah, it's the topic that nobody really wants to think about, but everyone, really needs to understand. We're talking about thermal runaway.
That phrase alone sounds dramatic.
It should. It absolutely should. Thermal runaway is the critical safety challenge where you get so much heat that it causes a catastrophic failure inside the battery pack.
And that leads to a fire.
Not just a fire, but a rapid, uncontrolled fire propagation. I mean, it is the worst case scenario, and the entire industry is working furiously to prevent it from ever happening.
Absolutely. And our mission today is to cut through all the marketing noise, ignore the aspirational press releases, and just look at the hard facts as of 2025.
Right.
We want a clear snapshot of which major automakers are genuinely leading the charge in these advanced thermal safety technologies based on the material you shared. So if you're shopping for an EV or maybe preparing for a meeting, what are those little nuggets of knowledge that explain why some cars are just inherently safer right now?
Okay, let's unpack this. If you really dig into the engineering documents and the independent testing, you find something, well, pretty surprising. For years, the general perception has been that safety leadership, like engineering excellence overall, that it rests firmly with the legacy European and Japanese manufacturers.
Yes, the classic incumbents. You think Mercedes, BMW, Volkswagen.
Precisely. But what the sources are revealing is that the current leaders in tested advanced thermal management are not necessarily those groups. Instead, leadership has kind of pivoted east and west.
So who is setting the current benchmark then for fire prevention and for containment?
The documents point very clearly to BYD out of China and Tesla from the USA. These two companies have created this undeniable lead in applying specific proprietary safety features to the EVs that are being mass-produced today.
That is fascinating. It really implies that just being a long-standing automaker, that's no guarantee of leadership in battery safety.
It's a strategic difference. The whole framework of thermal safety leadership, it really comes down to four major factors that BYD and Tesla are just addressing more aggressively right now.
And what are those?
It's the battery chemistry. So are you using the performance-focused NMC or the more stable LFP? Then there's the physical structural design, the cooling systems, and finally the electronic management architecture.
Okay, let's jump straight into that top tier and explore those differences. Number one, according to this analysis, is BYD. What specific innovations are putting them at the top of the 2025 safety ranking?
What's so fascinating here is that BYD's prime safety advantage, it comes from a strategic combination of two things: chemistry and structure. They use their famous Blade battery technology, which relies very heavily on LFP cells.
LFP, that's lithium ferrophosphate. We hear that acronym a lot. For the average person, why is that chemistry so much safer than the nickel manganese cobalt or NMC that a lot of other manufacturers use?
It's simply much more thermally stable. I mean, NMC cells are incredibly energy dense. They pack more power into a smaller space, but they have a critical flaw. They release oxygen when they get very hot.
So they feed their own fire.
They feed their own fire, exactly. When thermal runaway begins in an NMC pack, the battery provides its own oxidant, which just drastically accelerates the fire. LFP cells, on the other hand, they don't release oxygen. The chemistry is just inherently much more resistant to overheating and runaway. It's a foundationally safer starting point.
So they chose the safer chemistry, maybe giving up a little bit of that peak energy density or range, but gaining a huge safety margin.
That's the trade-off. But they also compensated for that density issue with a truly revolutionary structural design: the cell-to-body, or CTB, battery pack.
Cell-to-body. That sounds intensely engineered.
It is. This CTB design, it means the battery pack isn't just, bolted to the floor of the car. It is integrated into the structural integrity of the vehicle itself.
Wow.
This dramatically increases its resistance to external mechanical damage, say from a severe impact. If you can use the physical structure to prevent punctures and internal short circuits in the first place, you've just eliminated most potential thermal triggers.
I see. So it's a dual approach. You've got these chemically stable cells, the LFP, and they're protected by an engineering shell that is inherently resilient, the CTB. That synthesis is why BYD is ranked first.
Absolutely. They prioritize making the pack chemically and structurally inert. That is the BYD philosophy.
Okay, that sets a very, very high bar. So who comes in second, and what's their engineering philosophy? The sources point to Tesla.
Tesla follows BYD, but their approach is a bit different. If BYD leads on that structural stability and inherent chemistry, Tesla excels in thermal management and cell containment technology. This really starts with their adoption of the 4680 Gen 2 cells.
Right, the 4680s, they're very highly publicized. What specifically about them aids safety?
The innovation begins right inside the cell with a design change they call full tab winding. Now, to explain this simply, just imagine electricity flowing through a traditional battery cell. It has to travel the entire length of the spiral winding, which creates resistance and, critically, heat buildup at the endpoints, the tabs.
Hotspots, the perfect trigger for a thermal event.
Precisely. Full tab winding, it essentially provides multiple pathways for the current to flow. This ensures a uniform distribution of both current and heat across the entire cell body. Hotspots are mitigated, and that uniform heat distribution is just critical for stability.
So they're preventing the heat from ever concentrating in one place. That makes perfect sense.
And they pair that cell architecture with some crucial material science. They employ these highly stable ceramic separators within the cell.
Those ceramics are tough. Our sources mention they can withstand temperatures up to 180 degrees Celsius. In a rapidly escalating thermal event, how much time does that actually buy you?
It buys crucial mitigation time. If a cell starts to fail, that ceramic separator resists melting or fracturing for much longer than a traditional polymer separator would. It's like an internal firewall that can delay the onset of a full short circuit. But the truly elegant design element for fire isolation is their serpentine cooling system.
Serpentine. I'm picturing a network of tiny pipes weaving around the cells.
That's pretty close. The system is designed specifically to isolate each cell, or maybe a small group of cells. So if one cell does go into thermal runaway, which is still possible even with all these safeguards, the serpentine cooling structure slows down that heat propagation to the cells right next to it.
So it's like having individual thermal firewalls for every single compartment.
Exactly right. This drastically mitigates the risk of a fire spreading throughout the entire pack. So if BYD leads with inherent stability and structural rigidity, Tesla leads with its advanced internal cell composition and these perfected external isolating cooling systems. They're the two benchmarks right now, just for different reasons.
And there it is, the 2025 reality. Chinese and American firms are leading on proprietary applied engineering solutions.
That's right.
Okay, so let's transition now to the European landscape. It's clear BYD and Tesla have set the bar extremely high. This leads us to the European groups. Are they following this same blueprint, or are they taking a totally different approach to catch up?
Well, broadly speaking, most of the legacy European groups are, I would say, playing catch-up, particularly in integrating these specific advanced structural safety solutions, things like the proprietary CTB design.
So if we look at, say, Stellantis, Mercedes, and BMW today, what is their general status quo?
Their status quo involves using various battery technologies, often from outside vendors, both LFP and the more common NMC. But the crucial point is that as of 2025, they generally don't match the advanced structural design of BYD's CTB or the proprietary cell technology of Tesla's 4680s.
So they're improving, but they're not leading.
They are progressively improving their cooling and management systems, absolutely, but they are not the technological leaders in thermal safety right now.
But there is a standout in Europe, and that's Renault, thanks to what looks like a very smart partnership and some quick technology adoption.
Yes, Renault represents a crucial step ahead for the European mass market because they made a really smart choice on chemistry. They partnered with LG Energy Solution back in 2024 for their EV division, Ampere, and this supplies them with LFP batteries.
Okay, so they've got the safe chemistry.
They do. Specifically, pouch-type LFP batteries that use cell-to-pack or CTP technology.
Right. We've established LFP is safe.
Right.
But we also talked about BYD's cell-to-body, CTB. What does cell-to-pack, CTP, actually achieve, and how does that compare?
That is a very important distinction. CTP is more focused on efficiency and simplifying thermal management. It gets rid of the intermediate module structure, that sort of cage that holds smaller groups of cells between the individual cells and the final battery pack housing.
So it just packs the cells directly into the outer case.
Exactly. This does improve energy density, which is great, but importantly, it simplifies the thermal path. Fewer structural layers means heat can be conducted and managed much more easily.
I see.
But while CTP is excellent for thermal management, it doesn't offer that extreme structural protection of BYD's CTB, which makes the pack a literal load-bearing part of the car's chassis.
Got it. So Renault gets this huge safety boost from the stable LFP chemistry and the efficient thermal design of CTP, but they don't quite have that same crash integrity focus as the Chinese market leader.
That is the perfect summary. Our sources were very specific on the ranking context here, saying Renault's solution is considered superior to many of the current NMC and less advanced LFP solutions used by competing groups like Stellantis and BMW. They have achieved a very solid, highly reliable third position.
This brings us to what might be the biggest strategic bet in the whole industry, the German approach. They aren't just trying to refine liquid ion tech. They seem to be trying to leapfrog it entirely.
Yes, if you connect this to the bigger picture, Mercedes and BMW, they recognize they're currently behind on the specific structural and cooling innovations that we see in BYD and Tesla. So instead of pouring billions into replicating CTB or serpentine systems, they are investing very heavily in the future race.
Which is solid-state batteries.
Solid-state batteries. And the chemical promise of solid-state, it's incredible, especially when you're talking about thermal safety.
Right, it's the ultimate prize for safety.
It is. You eliminate the volatile, flammable liquid electrolyte completely. That promise alone suggests the resistance to thermal runaway that no traditional liquid lithium-ion battery can ever hope to achieve.
Mercedes, for example, is doing deep testing on solid-state batteries they developed with the startup Factorial Energy. They're aiming for higher safety, reduced weight, better range.
And BMW is doing the same, testing intensely with solid power, focusing on safety, faster charging, and autonomy. But this all raises a multi-billion-dollar question, which is really the aha moment of our deep dive.
Yeah.
Why are these companies not leading the safety rankings right now if they're working on something that is chemically superior?
This is where it gets really interesting for me. I might be a consumer worried about safety today, but I hear solid-state battery and I immediately think ultimate safety. So why should I care about what BYD and Tesla are doing with their liquid ion tech right now?
Because the simple reality of 2025 is this. While solid-state batteries are chemically a step ahead, and they will very likely be superior for safety in the long run, today they are still experimental, or at best in early road tests. They just haven't been perfected for large-scale, high-volume, low-cost manufacturing.
So we're talking about a 5 to 7 year gap before I can actually buy a mass-produced car from Mercedes or BMW that has that level of inherent solid-state safety?
Exactly. Large-scale diffusion is years away, and for that reason, BYD and Tesla maintain the lead in consolidated, proven, and commercially available thermal safety technologies that you can go out and buy on the market today. You cannot buy a solid-state Mercedes tomorrow that achieves the structural crash safety of a BYD with a CTB pack.
So the German bet is a strategic, high-risk, high-reward move for the next decade, not a safety solution for today.
That's it.
So what does this all mean when we connect the dots? Let's summarize the current safety hierarchy for the listener who just wants to know who's winning the safety war right now.
Okay, looking at the 2025 safety ranking, the thing to remember is that leadership is fundamentally divided. It's between those who have mastered current liquid ion design and those who are betting on an entirely new chemistry.
Number 1 is BYD. They've prioritized that chemistry and the structural strength.
Correct. BYD's LFP chemistry, combined with that structural cell-to-body design, is just proving to be the most inherently robust and resistant to external forces.
The number 2 is Tesla. They've perfected the engineering philosophy of thermal management and isolation.
That's right. Tesla is relying on advanced cell technology, the 4680s with their ceramic separators, combined with that innovative serpentine cooling system that isolates failing cells. They focused on perfecting the management of heat, even when a failure begins.
And taking the third spot, a clear European leader in current safety, we have Renault.
Renault got there by adopting that stable LG LFP chemistry and integrating it using the modern cell-to-pack, or CTP design. It's an effective, modern, and highly safe solution that puts them significantly above many of their direct competitors.
And finally, rounding out the list, we have Mercedes, BMW, and Stellantis. They are improving, of course, but their current mass market tech is just less advanced than those top two.
Right. Their true leadership potential hinges entirely on the successful, rapid, and low-cost deployment of solid-state technology. Until then, they are playing a catch-up game on current structural safety.
It's a technological arms race, and the safety stakes are enormous. It's just fascinating to see the Chinese and American firms leading on the available applied engineering right now, forcing these legacy players to place a massive long-term chemical gamble. So here's a final provocative thought for you to chew on. Since the current safety differences, they derive from these extremely complicated things like proprietary structural design, think BYD-CTB, and these advanced isolating cooling systems like Tesla's Serpentine setup. The question is this: when solid-state batteries finally mature for high-volume production, which we estimate is years away, will the established players who are relying on that distant new chemistry, Mercedes and BMW, be able to quickly integrate the structural and cooling innovations already perfected by today's leaders? Or will the time needed for solid-state to mature leave them playing catch-up on chemical composition and applied engineering on two critical safety fronts simultaneously?
Always something more to learn in this evolving landscape.
Until the next deep dive, stay informed.